What does the mathematician have in his garden? Natural logs, roots, and stem and leaf plots, and which are also known as stem plots. And we'll be covering them in this very lesson. So here's some data. We're looking at quantitative data now, and how do we display them? This data is for the sum of 2 die after 30 rolls. So we roll 2 die, and I added them together, and I got 6. Rolled 2 more, got 9. So you wouldn't get 9 from one roll. So hopefully that all makes sense. All right. The simplest way to display this is something called a dot plot. It tends to look a lot like a bar graph. So we're going to draw and label our horizontal axis, include units for continuous variables if you have them, all right? And then you're going to scale the axis to make sure you can cover the entire span of data. Plot the values and put a dot above the value for the corresponding data point. And you'll find it's super easy. We'll go ahead and do a dot plot for this set of data. First of all, in our example here, it's helpful to know, is the data continuous or discrete? Well, die rolls, each individual die only has 6 options, 1 through 6, and when you add them up, that leaves you pretty much the span from 2 to 12. So depth, and you can't have 2.5 as an answer. So it's definitely discrete. The min, as I just said, is 2, and the max is 12. So I'm going to basically cross off each point, and then, well, first of all, I had to number my scale there. I'll cross off the 6 and I'll put a dot there. Then I'll cross off the 9, put a dot there, and the 10, and try to make them evenly spaced. All right, and then we have the 8 here, and then the 4, 11. So you can see it's building up. See how I'm trying to keep sort of an even spacing there? And there's a 2 and an 8. And then I just went ahead and put the rest of them in. So you can go ahead and copy that down yourself. And that is our dot plot. Now, once you've created a display of data, you should be able to describe it, whether it's for categorical or quantitative data. Now, for quantitative data, there's a special way to describe it. We have the center, unusual features, shape, and spread. Now, there is another acronym, which I'm also going to teach you. This one is really easy for the level that we're at right now, because we haven't talked about the other measures of variability and some of the other things that are coming up. So for center, we're just going to use the median. You learned how to calculate that in middle school, and basically it's the middlemost point. Unusual features, that means we are looking for outliers, points that seem unusually far away, or gaps in the data. Gaps are interesting. The shape is about the symmetry, and if we say it's symmetric, if you can like fold it in half and it's roughly the same, and we'll say roughly symmetric. If it is not symmetric, it is usually skewed, and it can also be uniform, so that might be a way to describe the distribution. Modality refers to the number of distinct peaks, and one peak is called unimodal. For right now, for spread, because I haven't taught you the other measures of variability, just provide the minimum and the maximum. So tell me the span of the data. All right. So if I were to describe this, and remember, there's more than one right way to describe the data. Some of this is very subjective, so you won't get dinged if your description is like, yeah, I could see that. So our center, that one's pretty easy to calculate. It's the median, so I like circle until I get half the dots, and half the dots are over here, and half the dots are over here. So the median is between these 2 points, so it would be 7.5. Now, unusual, we do have a gap at 3, but we don't really have any outliers. You might be tempted to say, well, 2 is an outlier. I'm not so sure it's that far away from all the data. Outliers usually mean unusually far away. The shape, well, we definitely have a peak at 9, but it's roughly symmetric. If I were to fold this in half, it kind of looks alike. I'm not going to, don't have a huge amount of data points. Probably would want more before I got real specific on the symmetry. The spread, the data spans from 2 to 12 in this set of data. So here we have described this distribution, okay? Could you argue that it was bimodal? Probably not, because even though it looks like it has a peak here, it's about the same height as these. So And it's, I don't know, this doesn't feel like it's bimodal to me. So there you go. Now I picked some easier graphs here that we can talk about the center and unusual features and spread and shape. So for this first one, the center is going to be pretty much right there in the center. It's symmetric and unimodal and no outliers or gaps. This next one, the center's a little trickier. So what I decided to do is I went ahead and shaded this sort of symmetric piece here. Then I thought, okay, I've got these two blue pieces, but if I add that piece up here, then that's kind of equal there, but I still have extra pieces here. So I'm going to say the center's just a little left of this center, that bar there in the center of the yellows, and say it's right about there. Okay. Skewed, left, and unimodal. So skew means it's, if you were to picture it, the way the average is pulled. And if you have sort of a tail going off, the way that tail goes is the direction of the skew. It's definitely unimodal. It's just one mound, and there are no outliers or gaps. For this one, the center, using roughly the same technique, I would say is right about there. All right. And this is going to be skewed to the right. And I would still say that's unimodal. I left it out. No outliers or gaps, so we're pretty good there. This one I'm going to say is skewed right. And my center is going to be pulled probably, you could say, oh, it's either here or here. You could probably put some pieces together. Maybe it's actually in this bar. All right. I would say it's skewed right. And there's definitely a gap in the data. You see that? And there's your outlier. This next set of data, the center, you could have said, well, it's almost right there, but because of that little bit of extra data gets pulled right here. Okay. And we'll say that it is fairly uniform and there are no gaps or outliers. Is it exactly uniform? No, but it's, roughly uniform. This one, the center, I would say, is right about there, roughly in the center. It's bimodal because it has two peaks and no gaps or outliers. So let's go ahead and go to the next type of plot, which is a stem plot. Here are some actual grades from a test in one of my statistics classes. Now, why wouldn't I want to use a dot plot for this? Well, I think the lowest grade in here is in the 50s, and my highest grade's in 100. So I'd have like 50 different piles. So the data is just too far spread out. The span is too big, and it would just not be as interesting if I plotted every single little point. Now, a stem plot is an easy alternative to display a set of quantitative data that has a broad range of values. And it has the added advantage that you get to see each individual point. So if I wanted to do a stem plot of your test data, you could see where you are in the class without anyone else knowing. So what are the steps to making a stem plot? First of all, you got to decide what your stems will be. Usually it's a tens place and higher, but it could be the hundreds place or higher. Ideally, you should have at least 5 stems. So what are the stems for my data? My lowest set point was in the 50s. So the tens place there is 5. And my high point was 100. So the tens place there is 10. So these would make up my stems. And you can kind of see them down here, right here in the graph. All right. The leaf that goes with the stem will be the digits to the right of the stem. So the number 80 would have a stem of 8 and a leaf of 0. Now, I think it's probably, if you're doing a stem and leaf plot by hand, and there are some online resources to do them automatically, but they are kind of a pain. So I'll tell you, Calculator Soup has a great stem and leaf plot, which I use all the time. But if you're doing it by hand because you're taking a test or something, you're going to probably want to make a preliminary one. And we're going to be putting each data point into a stem and leaf plot. So first of all, 80, there's the stem, and we just put the 0 there. All right. 97, the stem is 9. We put a 7 right there. 83 would be going right here. 86. Notice how I'm not writing 83. I'm just putting the ones place here. 77 would go there. 100 would go there. 68, 80 would add another 0 here. There's a 68, 58, 77, 77, 58, 86, and then 90, and the rest of your stem and leaf plot right there. So I just went ahead and filled it all out. Why is this a preliminary stem and leaf plot? The problem is that these lines are not listed in order. The only one that's in order actually is the bottom one. Here you can see 70061. So if we're trying to organize our data, we're going to want to rearrange that. So let's go ahead and rearrange the leaves so that they are in ascending order. So from smallest to largest, and here that you go. And that's our completed stem and leaf plot. Now, so there's 55, 58, 58, and 59. Those are our points of data. One thing you want to do is you want to add a key showing how to interpret it. So here this says 80, so that would be like this one right here. That represents a score of 80. So a key is an important part. So if you're doing that freehand on my test or on your AP test, don't forget your key. If you have a small range, you can duplicate the stem. So for example, let's say I was looking at grades on my reflection, which tend to be quite high. They tend to just be 80s, 90s, and 100s and 105s, you know? So that would not be a very big range. What I can do is I can split the stems. So let's say if I was splitting this 80 stem here, 0 to 4 will go with the upper stem. So I would have 8003. And then I would add another stem down here, and it would have 866. And this 9 would be 9001. Then I'd have 967. And then these are all in the same stem. One last thing, if you are ever dealing with numbers that are less than 10, what would the stem be there? What's the stem for 8? If it's just 8, the stem is actually 0. Now there's one other type of plot I want to show you, and it's called a comparative stem and leaf plot. And I added this data from another class. So what we're going to do is add the data in the first class to the back-to-back stem plot, and the leaves ascend going away from the stem. So here, that means the lowest is going to be here, and the largest are going to be on the left side. All right, so there's my stem and leaf plot. And you can see now it makes it easy to compare. For example, I have a gap here at 90. There were no A's in my second class. If I was looking at these, it looks like my first class did better. The average is probably close for the center. Looks like it's in the 70s, maybe the 60s really for my second class, and more in the 70s for my first class. So that is a comparative stem and leaf plot.